Okay, let's dive into one of the most common and honestly most contentious questions in the entire Homelab world. Can you really trust USB for your server? As our labs get smaller and smaller, crammed into these awesome, tiny, power efficient boxes, we've got to ask, does all that convenience come with a hidden and maybe catastrophic cost? So picture this. You found the perfect mini PC for your 24/7 server, right? It's quiet, it barely uses any electricity. It's a dream come true. But then reality hits. You need to add more storage, or maybe you need another network port, and you suddenly realize these tiny little boxes have 0 PCIe slots, or extra drive bays like a traditional server. You've hit a wall. And that right there is the big dilemma. We absolutely love these small form factor servers, but because they have no room for internal expansion, we're forced to rely on pretty much the only high-speed port they have, USB. We're basically taking this consumer-grade port and forcing it to do a heavy-duty industrial-grade job that, well, it was never ever designed for.
At the very heart of it, the problem is a fundamental clash in design philosophy. See, USB was designed for transient things: keyboards, mice, flash drives, stuff you plug in and unplug all the time. But we're trying to force it into this persistent 24/7, high-reliability server role. It's kind of like asking a bicycle to haul a freight train's cargo. Something is bound to break.
So let's start with the absolute highest stakes use case, your data. It is so tempting to just grab one of those big multi-drive enclosures, plug it in with a single USB cable, and call it a day. And this is especially true for folks who are using advanced file systems like ZFS, which is literally built from the ground up to protect your data from corruption. It seems like such an easy solution, but it can be a recipe for total disaster. And this is where it gets really, really interesting. The experts on this, they're not just saying, it's a bad idea. No, they are unanimous and they are forceful. They say it is an exceptionally bad practice. It's not just about a drive randomly disconnecting. The consensus is that using USB for ZFS is actively dangerous to the integrity of your data. It just completely violates the core principles that ZFS is built on. Okay, to really understand why it's so dangerous, we have to look at a case that is the definitive smoking gun. A user did everything right, or so they thought. They set up a ZFS mirror, which is basically a RAID 1, using 2 identical USB drives. The whole point of a mirror, of course, is to protect your data if one of those drives fails. But that is not what happened. After a system crash, ZFS did its job. It scrubbed the data, checked for errors, and it found 120 of them. But here is the crucial, absolutely terrifying part. It found the exact same 120 errors on both drives in the mirror. Not different errors on each drive, identical ones. And that right there illustrates the danger perfectly. Think about it. The only possible way for both drives to have the exact same corruption is if the data was already damaged before it was ever written to either disk. The USB bus, the controller, the enclosure, something in that chain corrupted the data while it was in transit, and then it just dutifully wrote that same corrupted data to both sides of the mirror. It completely defeated the very protection it was supposed to provide. So if you are absolutely 100% determined to use USB for storage anyway, your performance and your stability are going to depend entirely on a modern protocol called UASP, which stands for USB Attached SCSI. Think of UASP as a multi-lane highway for your data. It lets you queue up multiple commands at once, just like a proper SATA drive. Anything using the older bulk-only transport protocol, that's like a one-lane dirt road. It is an absolute non-starter for any serious server workload. What's actually inside your USB enclosure is also critical. And hey, guess what? Manufacturers almost never tell you what they used. The cheap, bad ones use something called a port multiplier, which takes one signal and splits it out to all the drives. It's notoriously unreliable and a huge performance bottleneck. The better, good enclosures use an internal USB hub, which gives each and every drive its own dedicated controller. That means if one drive has a problem, it doesn't take all the others down with it, and you get way better performance too. All right, let's shift gears over to networking, where this whole USB dilemma gets even more complicated. A super common Homelab project is building a custom router with a mini PC. But since those little boxes usually have only one network port, what does everybody do? They grab a USB network adapter, a little dongle to add a second port. Unfortunately, this might just be the single worst job you can possibly give a USB adapter. A router has to run 24/7 under constant load. And these little dongles,
They're infamous for overheating and slowing down to a crawl. They are notorious for just randomly disconnecting, taking your entire network down with them, and maybe worst of all, they're a software ticking time bomb. A simple OS update can break the driver and take you completely offline with zero warning.
But wait, there's a huge hidden problem here too: CPU overhead. See, unlike a proper PCIe network card that has dedicated hardware to handle network traffic, a USB adapter is basically a software device. It forces your main CPU to do all the heavy lifting. At just 1 gigabit per second, a USB NIC can eat up an entire CPU core. A real PCIe NIC barely even registers. This creates a massive hidden performance bottleneck.
And here's the real kicker. Your success is a complete and total lottery, and it all depends on your operating system. The most common Realtek chipsets, they're mostly fine on Linux. But on FreeBSD, which is the OS that powers the super popular pfSense and OPNsense router software, those exact same chipsets are considered catastrophically bad, like completely unusable. You are literally just rolling the dice on whether your network is going to work at all.
So after all that doom and gloom, what's the right way to fix these expansion problems? Don't worry, it's not hopeless. There is a good, expert-approved way forward for both storage and for networking that lets you dodge these USB pitfalls completely. For reliable external storage on a NUC or a mini PC, the answer is Thunderbolt. Now, even though it uses the exact same USB-C plug, let me be clear, it is not USB. Thunderbolt is a direct extension of the PCIe bus in your computer. It completely bypasses all the flaky abstraction layers and reliability issues of USB, and that makes it the only truly good choice for high-performance external storage, especially if you're running ZFS. And for networking, the expert solution is this really clever setup called a router on a stick. It brilliantly avoids those unstable USB dongles by using virtual LANs or VLANs to run both your internet traffic and your local network traffic over that single, reliable, built-in network port. All you need is a managed switch on the other end to separate the traffic back out. Yeah, it's a little more complex to set up, but it is vastly more stable and reliable. Now look, this doesn't mean USB is useless. Not at all. It's an acceptable compromise for non-critical jobs where a failure is just an annoyance, not a full-blown catastrophe. We're talking about things like a Plex media library with replaceable data, or maybe a secondary backup target where a failed job can just be rerun. A low-bandwidth management port? Sure, it has its place. Okay, let's pull all of this together and get to a final, actionable verdict. The key here isn't to think about USB as just good or bad. The real key is to think in terms of risk. What are you willing to risk? So here's the takeaway framework. Using USB for your main ZFS data pool or for your primary router interface, that's a red light. It's an unacceptable risk of either data loss or a total network failure. For your Plex media library, where the data is replaceable, that's a yellow light. Proceed with caution and please have good backups. And for something like a secondary backup target, that's a green light. It's an acceptable and totally appropriate use. Ultimately, that choice between convenience and reliability, it's yours. There is definitely a place for USB in the Homelab, just probably not for your most mission-critical systems. Now that you understand the real risks involved, you can build your lab with your eyes wide open. So the only question left is, how will you build yours?